we've got two regular hexagons here, and the smaller hexagon is enlarged to the larger one with a length scale factor of 2. So I'm going to call that hexagon 1 and this hexagon 2. So the length scale factor going from 1 to 2 is equal to 2. That means the area scale factor, also going from 1 to 2, is 2 squared, which equals 4. That may or may not be necessary. So our first job is, given that OA is vector A and OB is vector B as marked, our first job is to write down an expression for the vector AB. Well, if I want to travel from A to B, I must go the wrong way along vector A and then the right way along vector B. So this is going to be equal to B minus A. And that's the first result. Our next vector they want us to do is Ki, which is this vector here. So somehow we're going to have to bring our vectors so that we can do our journey from K to I. Well, we've just worked out a horizontal vector going in this direction, which will be parallel with the vector Kj. We're told that the length scale factor from the small hexagon to the large hexagon is 2. So this vector must be double AB. So this is 2b minus 2a. So let's add that straight away to our journey from K to I, because we're going to have to travel along here. Yes, I know we're going to be traveling on from J to I, but let's just write this one down. So this is 2b minus 2a. Now we've got to consider the vector Ji. Well, the vector Ji is clearly parallel with vector B, and it is in fact vector B multiplied by the scale factor. So this vector turns out to be 2b. So I'm going to have to add 2b to our result so far. So this is equal to 4b minus 2a. And there's the next result. Now they want us to find LD, which is this vector here. Okay, here's LK. Now LK is parallel geometrically with vector A, but it's going the wrong way. And it's double the length. So this is vector negative 2A. To do our journey from L to D, we have to go down L to K and then halfway along the vector we've just found. So bringing that all together, I can say that vector LD is equal to, travelling down here, negative 2a plus half of what we've just found. What we've just found is 4b minus 2a, so this is plus 2b minus a. Pulling the a terms together, this is 2b minus 3a, and that is the third of the results they require. Okay, part B. Question that never seems to want to stop. The area of triangle AOB, which is this guy here, and they tell us that OAB is equal to 5 centimeters squared. And they're asking us to find the grey shaded area. Well, if we can find the area of the whole of the small hexagon, we can use our area scale factor of 4. That will give us the area of the large hexagon, and all we've got to do is take them away from each other. So area small is equal to, how many sections of this? 1, 2, 3, 4, 5, 6. So it's 6 times 5, which is equal to 30. The area of the large hex must be equal to 30 multiplied by 4, which is equal to 120. So therefore shaded area is equal to 120 minus 30, which is equal to 90. And this is centimeters squared. And that's your answer.